This meeting is being recorded.
In Chapter 13, Problem 5, we are asked to show the reagents that we could use to prepare each of the following ethers using the Williamson ether synthesis. And then we will explain why we chose those reagents. So, if you recall, in a Williamson ether synthesis, an alcohol is deprotonated in a first step to form an alkoxide ion, and then in a second step, that alkoxide functions as a nucleophile to attack an alkyl halide. So, generally, we need the less sterically hindered substrate to be our alkyl halide to perform a Williamson ether synthesis. So for compound A here, we could use a secondary alcohol here, our cyclohexanol. And then, as mentioned in step 1, we could deprotonate that alcohol using sodium hydride as a base. And then in step 2, we could use this alkyl halide as our other portion of the ether here, right? So that iodide is our leading group, and we will perform this SN2 reaction. In for compound B here, we could start again with alcohol here. So, actually, in this case, we would start with this alcohol over here as our secondary alcohol. And then we would use this primary alkyl halide as part of our reaction sequence here in part 2. So something like this. Actually, something like this would be our primary alkyl halide. And in step 1, again, we would use that base, that sodium hydride. So again, we want the less sterically hindered substrate as our alkyl halide. So we have that SN2 reaction curve. So let's take a look here at compound C. So again, we would use this as our alcohol, the more sterically hindered alcohol. Then we would use methyl iodide as our substrate in part 2. So first deprotonate, and then methyl iodide can be used to perform this Williamson ether synthesis. In our last example in part D here, we have what is called an intramolecular Williamson ether synthesis. And this means that our alcohol and our alkyl halide are within the same structure. So we could have something like this. And this will be our alcohol portion. And we could perform this intermolecular Williamson ether synthesis using just the sodium hydride reagent. We could not use a structure that looked like this, where this was our alcohol portion, because then we would have this tertiary alkyl chloride over here, and this is not a good substrate for an SN2 reaction to occur, so we could not use that.